So before we get into the actual slides, I'll say, what I find interesting in healthcare AI specifically is kind of the term AI has almost like a magical effect on healthcare marketing. It's really marketing specifically. The vast majority of AI systems I see in healthcare companies, and many of which even have AI in their name or use a .ai kind of domain website, is mostly marketing. Some part of their system may use a third-party natural language processing software like Amazon Comprehend Medical, or deal with large amounts of data or use some kind of machine learning. But even though they market on as if they're on the cutting edge of AI, like companies you see in other industries, Tesla for autonomous driving. In gaming, you see Stockfish for chess, Sessi and other ones also for chess. But AlphaGo and Go, OpenAI. In art, you have Dolly. So we'll go through a few of these examples. But as we get started here, I'll also say that I heard a great quote from Arshin Karande, who does AI ethics at Cambridge University. And he said that today, AI is more of a marketing token that has become a, quote, incredibly loud badge that is quickly coming to signify nothing. So on that, I'll get started into the healthcare hype. I'll just do a brief one on this. Let me fix the slide too. Alt. Yeah. So this webinar that we did this morning was sponsored by Ionix Technologies. They do all this stuff. I am Maanas Samant. I am a physician. I'm a clinical product expert. I have more than 10 years of experience in all kinds of random stuff in health policy, health tech quite a bit, and as well as health optimization. I worked at Cedars-Sinai Medical Center in Los Angeles. I also worked as a physician consultant for several years at Accenture, and I am also leading the healthcare vertical at Ionix. So let's get into a bit of the hype. And before we get started, I took this tweet. It's actually not that retweeted, but it's only has a couple thousand retweets. But she wrote in 2016, a cool thing to remember is that whenever someone says AI, what they're really talking about is, quote, a computer program someone wrote. So I think that's something to remember as we look at AI today. And of course, I'll get into the specifics of kind of like narrow AI and general AI and in the future, kind of looking at a future state. But when you look at all of these companies, and the companies I'm going to go through, I either know personally or I've come across personally, and they are actual companies who are doing business, earning revenue, etc. These aren't like all going to be studies and random things, but I'll get into those as well. So the first thing we're going to look at is Cambio, and this came across my feed as something that was doing some stuff to predict stroke. So I was like, okay, cool, what's going on? It was a big headline. As usual, they always have these big headlines, but when you read below the headline, it's usually a study with poor parameters and things like that. So I took this other image you see here from medcalc.com, which is a free website. You can just kind of basically click and get this score. So what Cambio did was that they basically calculated this score, which I'm not sure how to say it, but basically all the twos are things that count for 2 points, and it gives you a total score. So when you look at this, it's CEH is congestive heart failure, hypertension, age is worth 2, which is the AA2, and then diabetes is worth 1, stroke is 2, that's why it's S2. Then VASC is vascular disease, and the A is age. It's just like a weird acronym, I guess I'd call it. So that's basically what's going on there. And you could easily calculate this on a site like MedCalc, or doctors can kind of just look at these things and understand what the calculation is. It might be built into your EHR, but this basically will look through your data and kind of score it for you. One thing that I can say, having worked in multiple hospitals and hospital systems and EHRs, is that there's probably going to be a lot of alerts, and I don't know how many of them are going to be false positives, which is the worst, because you're just going to be clicking alerts, and there's something we call alert fatigue that is not designed well in healthcare. So the user experience is generally pushed to the side, and hospitals claim it's for safety, but it's probably more like a CYA for getting sued or something. But overall, it's like I'll just push every possible notification to the doctor or nurse and make them clear it, and then we have a log of, hey, we told you that there was a problem and you guys ignored it. But if the true positive rate is really low, if you have a ton of false negatives, or sorry, a ton of false positives, you're gonna of course start ignoring these alerts. So the first one, this is a real company in Silicon Valley called LeanTaaS. I visited their headquarters up there the same day I visited Google, actually. So they use the term AI literally everywhere on their website. They have a quote to eliminate operational bottlenecks, generate revenue, and increase access to care. So this is a revenue-based play, not really patient-centric, but that's kind of par for the course in U.S. healthcare. Things are generally going to be kind of revenue-based, and that's just the way that the model works. So you'll see, so basically on their website, you'll also see their value proposition. It's maximize time seeing patients in the OR, so in the operating room, and they claim to get $500,000 per year per OR for the hospital system. So that's a pretty big gain for them. So they say that they use AI to whatever proprietary thing, and they're going to make you more money if you use their system and integrate it with your scheduling. It is unclear how patient access is affected, but that's a term that they use as well, and they claim to improve. May or may not be true, but that is one company that is doing well as far as revenue and headlines. The next company is Giant. I know a couple of really smart people who work or have worked for Giant. One I worked with at Cedars-Sinai many years ago, and the other I worked with at Accenture. He's a physician as well, I believe he was their CMIO for a while. Anyways, so their AI is a chatbot. Their case studies are kind of like total revenue, contact center savings, and new patient revenue. So they have things like that, and basically this chatbot is used to triage, which is assigning degrees of urgency to wounded or ill patients. So if you go to the hospital with like a tummy ache, and I come to the hospital with 2 broken arms, the triage will be like, well, this guy with 2 broken arms needs to be tended to first because it's more urgent, and I will kind of jump the line, and you'll have to sit there with your tummy ache. So that's what triage is. So basically this chatbot will triage, and it found a lot of success during the COVID pandemic doing this. So kind of imagine a questionnaire, but more interactive, so it feels more real time. And like I said, the case studies on their site are total revenue and things like that. So they're again a revenue play that install this chatbot, and we will triage more expensive patients to you. And we'll get them through the door. They do kind of like a front door service that's all conversational with this chatbot. ClosedLoop.ai. These guys are local to me here in Austin. I spoke to this company a year or so ago. Again, their website is full of AI references. A lot of things that they talk about are things that I worked on at Cedars-Sinai a decade plus ago. So that's like readmission prevention. So I did a project on 30-day all-cause readmission reduction. So basically, when you discharge a patient from the hospital and they come back within 30 days, it counts against the hospital due to some kind of quality metrics. So it's like you didn't do a good enough job. But again, these are all-cause readmissions. So if I treat an 80-year-old man for heart failure and I stabilize him, everything's going fine, I discharge him. If he slips and falls in the shower the next 30 days, it comes back to the hospital, you still get dinged because it's an all-cause readmission. So that's how this readmission process works. So Closed Loop is a company that will reduce things like that using their AI. And yeah, they're again primarily a revenue play, revenue optimization. They have some patient references sprinkled in, as these companies generally will in marketing. But if you're looking at really who their customers are, it's B2B play with the care system. Bayesian health is an interesting one. So this was an article from July 2022 that was titled, quote, AI could prevent thousands of deaths yearly. It's a very sensational title. But I read the actual study, not just the article. And it was a retrospective analysis, which means you get data and look backwards. And the outcome of mortality wasn't even judged because, again, it was retrospective. You already know what happened. So saying AI could prevent thousands of deaths yearly is definitely a bit much. And they talk about kind of sepsis in this. So it's sepsis isn't really causing death in a short-term rate. Like you're looking more like septic shock. But I would say, the sensitivity that they found is the same as existing tools, and it doesn't diagnose sepsis or anything. It's supposed to be an early warning system that the patient may have sepsis. And what I didn't like about it, I mentioned a little bit earlier, is that you get this early warning system from the patient, from the system about the patient, and the physician has to do something or the nurse has to do something. But what they don't talk about is how many false positive alerts their AI would give. So like I said, they just push every alert to the system, and they hope that they're doing something positive, which they may or may not be doing. But regardless, that was this one here. And before I go into the next one, I did see an additional hype yesterday, which I don't have a slide for, but it popped up on my LinkedIn. There was a company called CAIRE, ICH, CAIRE, and they claim to detect intracranial hemorrhages in CT scans. So that's like a brain bleed. So, and when I looked at their actual study, I actually posted this comment on their study, but I'm sure beyond a few people, no one's gonna really read it. But basically the study was rigged both to succeed and it wasn't really relevant to real life conditions. So basically what they did was they shared that their N, or like the number of subjects in it, so it's actually an N of 532, but that's 532 CT scans, and they were viewed by just 3 radiologists in the study. I believe they said that they had an average of 13 years of experience. It was 2 years, 3 years, and 34 years of experience, respectively. So these 3 radiologists were the only ones looking at the scans, and they basically showed them all 532 scans without assistance. And then 48 hours later, they repeated those exact same scans. So that's what they called a washout period. So I guess they're supposed to forget all of these scans in the next 48 hours. And then they repeated it with assistance, which showed slightly improved results. And they gave all of the credit of those single-digit percentage improvements to the AI. Not that they had already seen them 48 hours earlier. And the last piece of kind of hype on this CARE ICH one was that they don't have any patient history or clinical context for any scan. So that does not mimic real life conditions at all. You don't have radiologists just looking at scans and doing things. You will have information like patient's age, what their symptoms are, and things like that. So you can form a more complete picture than just the picture in the CT. So that was an additional hype I wanted to add. I didn't put a slide on it, but that was for CARE ICH. Now I do want to compare healthcare to other industries. Tesla is kind of a incendiary topic. People love it or hate it, but if you look at what Tesla's doing for autonomous driving, I have a video here. It is kind of choppy because it's like a small video that I'm maximizing, but hopefully you can see how many things it's calculating in real time. You can see the stop sign. You can see all of these parameters are popping up. It's doing a lot of calculation. It's looking, here's the right turn. So it's driving the car by itself and it's analyzing all these real world conditions. It sees the stop sign and stops. So this is all, Tesla's autonomous driving. Their AI is based on a neural network, which we'll talk about in a future slide. So this is something super cool to me. More than just kind of the things we're talking about in healthcare so far. All these real life examples of companies doing AI in healthcare are like, scheduling and a chatbot. We had chatbots in the 90s, Smarter Child on AIM and stuff. So those things don't excite me as much as, you can go on YouTube and watch Andre Carpathy, who led the autonomous systems at Tesla. He has really cool talks. You could, even if you're like a layman in AI technology like I am, you can really go and understand a lot and get a lot out of his talks. He makes it pretty relatable and simple at times. And then comparing it to other industries continued kind of, you see Tesla, we already talked about in gaming, since I'm currently streaming this on Twitch. We'll do the VOD on YouTube, but chess, we have Stockfish, we have Ceci, we have all these, really great AI programs that, whether or not they're AI, they are computers and they're engines, we call them, and they are able to, play these games at a very high level. AlphaGo is kind of the same thing. They beat all the best Go players in the world. And the older version of chess stuff, like, Deep Blue versus Kasparov, that's back when it was kind of a match. Nowadays, I believe the highest Stockfish is Stockfish 15, which is like a 3,800 ELO rating. So they'll beat even, Magnus Carlsen 100 times out of 100. They're just on the next level. And same thing with like AlphaZero, Google DeepMind stuff. So you can look at those. And then art, DALL-E is super impressive. I have a picture on the next slide about DALL-E. It's basically you type in a sentence, like I believe I typed in a silly robot with arms extended, and it gave me this picture here. You could see. So it just did that in a few seconds based on my sentence. If you go to DALL-E.com, you can do 50 for free and see what comes up. It's super fascinating, I think. Moving on to the next one. So like general versus narrow AI. So artificial general intelligence is really a theoretical application of generalized AI in any domain that can solve any problem. It's not real. It is something that we just kind of, let me see if I can turn the gain down a little. It is something that's kind of like theorized, and it's not going to be in kind of real life, I guess we could say, anytime soon. But artificial narrow intelligence, or weak AI, or task-specific AI, is an AI program to perform a singular task, such as facial recognition, speech recognition, and things like that. Let me turn my gain back up. Driving a car, narrow AI does like simulation of human behavior on a very limited set of parameters or constraints and context. So, and some more of these like speech and language ones, I'm not going to say the name, but ALEXA, because I kept setting it off this morning, my Amazon device behind me, and other things such as Netflix recommendations also suggest shows based on your activity. So it is kind of, narrowly trained to, complete a specific task based on a set of parameters. The Turing test, I think it's pretty popular. Everyone has heard of the Turing test. Alan Turing, he called it the imitation game. It's basically a game with 3 participants, and they talk, and you have to figure out which one's an AI, which one's not a human. And computers, they say that if there's something that could trick people into thinking that they're a human, they have succeeded to pass the Turing test. Some people believe it's good. Some people think it's too narrow as well. I believe that humans are kind of idiots and will believe anything. So, people believe the Nigerian prince scam emails. So I'm not surprised that they'll think anything is human that's just like an insane email bot account or whatever. But the Turing test is something that's also going to be talked about when you talk about AI. The neural network, I'll talk real quick here about, because I mentioned on the previous slide with Tesla. So these are continuing overviews in kind of other industries and other places and other types, because the type that we see in healthcare companies that are producing revenue and actually marketing AI is kind of wildly different from these. So a neural network is kind of, it's a bunch of variables in a stack, like a complex tree of dependence. Each node in the stack is an equation, so a list of connections from where to go and where to get input values. So when the neural network is created, it has nothing. It hasn't learned anything. But you show it something and it responds. And then you tell it, like, good job, neural network, and pat it on the head like a little puppy, or you say bad neural network and whack it in the nose with a newspaper. So depending on if it was right or wrong. So if you do that a bunch, it'll eventually juggle around the variables until it gets the good response more than the bad. Just like dogs, just like humans, neural network is this. So an example that I saw in Tesla is basically the cars were unable to tell if the car in front of it was a bicycle or a car. If the car had a bicycle mounted on the back, like on the trunk, which I see pretty often, you'll see like a biker who's taking their car up to the mountains or whatever, or to the trail, and they just kind of hitch it to the back. So the car would keep it, but the Tesla would keep saying like car, bike, flipping back and forth. So what they did was they were like, okay, go to every instance where we had a problem saying this is a car, this is a bike. So pulled up tens of thousands, hundreds of thousands of times. And as they went through, it's just like, okay, what do you think this is? Car or bike? And Tesla would be like, bike. And you'd be like, wrong car. What is this? Car, bike. Bike. Wrong. Car. And you do that enough, and then Tesla's like, okay, car. Is this car? Is this a car? Is this a car? And once you tell it enough, then you send that update back on the next Tesla update to every single Tesla. And suddenly, seeming like magic, every Tesla now can properly identify which is in front of it, if it's a bike mounted on a car, if it's a car or if it's a bike. All Teslas, regardless of when they were made, now can make that distinction because of how they do their over-the-air software update. So I found that was super interesting and a real-life example of a neural network. Machine learning, this is kind of like a part of AI. I used to hear it a lot more before AI became the magical badge that Arshan Kurande at Cambridge University mentioned today. But machine learning algorithms, they basically build a model based on sample data known as training data. And based on this training data, they can make predictions or decisions without being explicitly programmed to do so. So a lot of this I see also, it is kind of like a bit of the neural network that I explained in the last one of like what a neural network is and how it learns. It still learns this kind of machine learning thing. The training data, maybe real life data in that situation. But it basically is going to quote unquote learn. So I think that's a super interesting one too. Some of the bigger players in this, so Google, they should say probably fetal GA, not baby GA. That's a mistake. But it's basically, this also came across my feed the other day and I commented on it. Basically, it's, Google did something for people in Africa who don't have access to a hospital. They can use their smartphone and kind of scan like a pregnant woman's belly, and it will guess the age of the baby, the gestational age, how many weeks old the baby is. And as it gets closer to delivery time, it will also diagnose fetal malpresentation. So that basically means that, if you're, 36, 37 weeks pregnant, your baby is pretty big. It can't turn around that easily. Although it's still possible. There is something called version, external cephalic version, that you learn in medical school or in obstetrics and gynecology, really, but obstetrics. So it's how to kind of feel where the baby's head and back is and see if you could kind of manipulate from the outside to make sure the head is going down. Basically this would show a fetal malpresentation as well in those late term pregnancies, and you would be able to understand, okay, this baby looks like its head's down, we can prepare for delivery, or hey, this baby is in breech, its back's down, we need to take this mother to the hospital to make sure that this baby is born safely. IBM Watson, they were, a decade plus ahead of everyone else, and they had Watson on Jeopardy, and it was showing off all these things. They had IBM Watson Health, which my former boss at Accenture worked at, and I did ask him about it after Accenture, and he was like, he did not have good things to say about IBM Watson Health at that time. But last year, I spoke to them as well, just before they sold their practice, and they basically got rid of their IBM Watson Health. I don't want to call it a failure, but it did not work out well for them. So for Amazon, I probably should have muted mine, but the ALEXA behind me also is doing some stuff with medications. I know that they're working with First Data Bank. I don't know to what ends, but they are working with First Data Bank, which is a medication database. They're like the leaders in the field. So anything you want for medications, you can get from their API. A really good company. And Amazon Comprehend Medical, I played around with for 3 months on the free tier. They can basically do like I could send a text. It's almost like when you use Postman, you send text to an endpoint and you get back a response, right? So rather than getting back like a JSON object or whatever, you get back this string when it tells you kind of like, okay, my confidence interval is this for this, and this is what you're trying to say. So I was messing around with it for medications because I was thinking of elderly folks are on a ton of medications. It's really hard for them to communicate what those medications are. So what we call medication reconciliation becomes difficult. So I was trying to see if we could use AI to improve that. So I was, sending typos on acetaminophen, and I was, doing stuff with like, wrong names and things. And, it would send back confidence intervals like 85%. I think you're saying this, 77% this, 90% this, and it would, kind of rank you like this is what you're saying. And it was pretty good. And the last thing, Microsoft also has some health investment in AI. I'm not going to super get into that. And this slide was for Ionix Technologies. Ionix does work as a tech partner for HealthTech, but not core AI development. Basically, if you look at the core AI, it's a very small component of all of these healthcare companies. Sure, that's what they market the most, but it's really how it's implemented. So on the clinical consulting part, like I mentioned, I was a physician consultant at Accenture. So it's really health AI should hit the right target. If you are going to be a triage chatbot, you want to make sure that you're targeting the correct path, even if it's for revenue. Although I'm much more interested in patient outcomes, but that's fine. Defining the clinical workflows for AI. Another thing I mentioned, that alert fatigue. If you want to make an actual impact, not just make headlines, you do want to make software that is, has good user experience, has good usability. You want it to be designed well. Theoretically, hopefully someone wants that. Large hospital systems, and like I mentioned, all the companies are basically looking at revenue, but clinical workflows are important. Doctors already spend 4.5 hours a day just inputting things into their EHR, their electronic health record. So reducing the amount of time that we have to spend in front of our computers would be nice. And custom technology builds, digital health and apps, done that, been there, done that. And ensuring compliance for privacy, governance, and regulations is another thing. And last thing, these are some of my contact information here. If you want to get in touch, tell me about some cool healthcare AI things that I don't know about that are on the level of DALL-E and Tesla and OpenAI and things like that. I would love to hear more. I am pretty skeptical, so may or may not be easy to convince me of this, but I am also, like I said, open-minded. So I do read all of these things with optimism, if not a bit jaded optimism, but still optimism. But like I said, a lot of them seem rigged to succeed and not relevant to real life conditions, and they're kind of working more on headlines and hype rather than kind of progressing forward. I just think the incentive isn't really there in healthcare. The healthcare incentive in America anyways is more revenue based. There was also, something I wrote about over a year ago, which is the obstetric, the OBED, they call it the obstetric emergency department. And is basically anyone who's pregnant goes to the hospital creates almost like a fake emergency, and they're able to bill the patient way more, claiming it was an emergency, and there's not really an easy way to fight it. More and more hospitals are doing it, and private equity firms are buying practices, buying hospitals to implement this system because they see the free money there. So if you go for a checkup, you're very close to delivery. The hospital will take you, sometimes it's separated by a curtain, sometimes it's not even that. You'll go there, if everything seems routine, they send you home, and then you get a bill that says it was an obstetric emergency, and you're being charged over $1,000 or whatever, rather than whatever you should have paid. But things like that are commonplace, unfortunately, and that's kind of an example of why healthcare is more focused on revenue. And so even these AI plays, while while the CT scan hemorrhage thing would look like they were trying to help patients, looked a bit more kind of marketing based to me because it was like poor parameters and not relevant to real life. But in real life, like I said, it's more about the money. Get in touch if you'd like to share any good news, or if you're looking to get something built, or if you have an AI application you need some consulting or development on. All right, that's it. Thanks.